Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we took a look at a basic material system, more of a discussion as to how we would build a material system in the future. It's kind of good to start thinking about that kind of stuff. Check out that video if you haven't already. And today we're going to continue on with the shader class, make it a little bit more formal. Right now, it's just a basic class that only works with OpenGL. It's not abstracted in any way, and it just kind of does what we want it to. We might as well have written it in Sandbox. It's that kind of non-integrated into our engine. So we're just going to clean it up a little bit today, and also talk about how we are going to actually move it into more of an OpenGL kind of fashion. Because unfortunately, the topic of writing a shader class, as you can hopefully imagine, right, is something that's very, very difficult. Because at this stage, we have very little actual functionality to do with shaders. If you were to sit down and actually write a shader class in Hazel right now, you would spend a week on it probably, because you need to write a lot of other systems. You need to tie it in with material systems, because in the big scope of things, if you open up like Unreal Engine's source code and you take a look at how they handle shaders and how they integrate that with materials and how all of that works, it's immensely complex. It's not just like it's not like 1,000 lines of code that you can just jam in and everything works. It's a whole architecture, it's a whole system. And since Hazel is all about me kind of showing you how everything works step by step, and not only showing all the code that I'm typing on screen, but also making sure that I'm kind of iteratively working on Hazel, meaning that, what we have right here, right? If we just like take a look for 1 second, what we have right here with like a triangle and then all of these quads being rendered, like with every kind of column being a different color, red or blue, that kind of stuff, we could spend 3 years rewriting this code, refactoring it to do this, because you could do this in like 200 lines maybe of just OpenGL code in one file and you'd be done, right? Or you could do this in Unreal Engine or like Frostbite or something like that, right? You could write it however you like. It's so complex. So I just want to get that into your heads that doing something like this from the get-go and immediately writing this amazing engine with an amazing material system, an amazing shader system, that is not something that we can actually physically do. If we were to do it, again, it would take 100 videos, and everyone will probably lose interest in this series because we've been making little squares for 100 videos. So I'm just kind of trying to structure it in a way that is both interesting to you guys, but also shows kind of almost like, a basic engine all the way up to like something kind of industry standard, something like AAA. So that's the goal of this series. Just to get that into your heads. Anyway, patreon.com/thecherno, best way to support this series. If this stuff is a little bit boring for you and you want to see like some physically based rendering or some like an actual kind of proper like model viewer, which has a real 3D renderer with like a camera and everything integrated into it, then check out patreon.com/thecherno. If you do help support the series, you'll get access to source code where I've already achieved all of that. And that'll kind of help accelerate your learning a little bit. And that is also what we're working towards with this series. So today, what are we going to do? Well, step one is going to be to refactor the shader class very slightly, just to get it out of the idea of being OpenGL only. Because right now, if you look at shader.h, shader.cpp, it has OpenGL code in it. It's tied to OpenGL. We want to get rid of that association. Second of all, we want to add more uniform functions. So at the moment, I think we have a matte 4 that we can upload and a float 4, because that's what we used for this color. We're going to make it so that we have all of the uniforms that we actually need to upload. And then third of all, I actually want to add some kind of color picker to our IMGUI UI, like I said last time, so that you can actually pick the color of all of these squares. Just for simplicity, we'll probably make all the squares the same color, but you'll be able to actually use a color picker in the engine to pick what color you want the squares to be. So that'll kind of just show dynamic uniforms being updated as you change the color, and that should be kind of a good test. On the topic of uniforms, I don't want to talk about uniforms too much. As I mentioned last time, uniforms are something that a proper uniform system needs a proper material system, because typically what you would be doing is basically using the material API. When you bind a material, when the renderer actually binds a material, you would typically just take all of the uniform values that you need from both the renderer and from the actual material that you're using, and then upload them as kind of one contiguous buffer right into the shader, right? Because you want to transmit all of that data to the GPU kind of in one batch. That is not what we're doing right now. That requires a little bit of setup. We need a proper renderer, we need a proper material system, all of that kind of stuff, and that's coming in the future very soon. You guys seem to have voted for 3D, and we'll have another poll as well just to make it more formal, because honestly, the polls on the YouTube videos I really hate. Like, they just give you no data. So I'll make a proper poll, I think, on my actual YouTube page as like a text post, because you can also do that, and that'll be like an actual poll. There'll be a link in the description. I'll mention it at the end of the video as well. But that will be like an actual poll where you can leave comments and discuss it, and it'll just be like kind of in the context of a poll, and you can see how many people voted and all that stuff. So that'll kind of be the formal last decision, I guess, that gets made as to if we do 2D or 3D first. But anyway, today, let's do all this uniform stuff. Let's add all the uniform functions that we need for OpenGL. Let's separate it into an OpenGL class. And let's see if we can change the color of these squares dynamically. Okay, so first thing we're going to do is take a look at that shader class. So as I mentioned, if we go to our shader class, this is shader.cpp. If we look at where it's located, this shader.cpp thing, if I go to Hazel, and show all files is what I wanted to do, and we just quickly take a look at where it is, you can see that it's right here. It's in Hazel renderer shader. What is this? This is a API independent and API agnostic API, a render API agnostic Hazel API, right? Hard to say and doesn't really make sense, but the point is all of this code should be completely generic. And you can see that in the case of our vertex array, in the case of both index buffers and vertex buffers, we do a switch to determine which API we use. Whereas Shader does none of that. Shader just has pure GL code in it. It has no switching. It's just a full class. That's not what we want. That's not what we want at all. So the first step is going to be to go into platform and to go into OpenGL, and then I'm going to add a new file, two new files. One's going to be called OpenGL shader.h, okay? And then I'll also make a OpenGL shader.cpp file. And then what I want to do is the CPP file, we're basically just let's go to the shader file. Let's open up our shader class, and I'm just going to copy everything because it's basically what we've written here is an OpenGL specific shader class. And I'll do the same for the CPP file. I'm just going to copy it straight up and paste it into here. All right, that's much better. So now what we'll do is make it specifically an OpenGL shader class like we did with vertex array, with vertex buffer, all of that stuff. We don't need to include this stuff, but we do need to make sure that we include Hazel, renderer, and shader.h, okay? This obviously becomes OpenGL shader. The destructor will also be virtual. Bind and unbind will end up being kind of virtual const overrides, like that. And then this stuff we're going to keep in this class because we don't want to expose this kind of API to the shader. Now, this involves a little bit of discussion, so we'll probably just talk about it as we go. But essentially, and we'll do the same thing that we do for all of our like API independent classes. So if you take a look at like, you know, buffer or something .h, you'll see that that we also have, you know, we have like a virtual destructor. We've got bind unbind, and we've actually done equals default here, which I guess we can do for here as well instead of this. But you can see that we've just got like we've got our like virtual destructor and a bunch of virtual functions that are pure virtual and no data members in here, and then like a static create function. So that's exactly the pattern that we're going to be following for our shader class. So this will just be pure virtual. This disappears because we don't want to expose it. What we will in fact have, and this is already done in the Hazel development branch, what we will actually have is just like a virtual void, you know, upload uniform buffer, right? But this will be a little bit more complicated because it will be different for like vertex shaders. It will be different for like material uniforms versus renderer uniforms because they might get uploaded at different frequencies. Therefore, they might be like actual different buffers inside the GPU. There's a whole lot of actual stuff that needs to get written for that to happen, but that's just a little bit of a peek into the future if you're wondering how on earth this system works. Now, you'll note that we do not expose anything into this shader class. We don't have our upload uniform mat4 or float4 exposed at all. So how do we currently with this system upload uniforms, you may be asking yourself. So the answer to that, as you'll see, is we're just going to end up whilst we will create a shader and it'll be a shader pointer, what we will actually do is basically cast that shader into an OpenGL shader, because clearly it's going to be an OpenGL shader object at this point because that's the only render API we support. And then by the time we start supporting other render APIs, we'll actually have that material system in place, so we'll never have to cast. So if that makes sense, that's kind of a way for us to skip ahead, but also be able to retain that functionality without writing a whole bunch of code that we'll never ever need. That's it. That is our whole shader class. Now we need a static shader pointer create function. Now, what do we have inside our OpenGL shader? We had a constructor which takes in a vertex source and a fragment source. So that's exactly what we'll paste into create. I'm going to open up vertex array.cpp and steal basically all the code in there, and that's going to replace the code inside shader.cpp. Obviously, we'll include shader.h, and renderer we'll also need to include for render API, and then we'll instead of this, we'll include OpenGL shader inside the platform. All right, so that is looking pretty good. Obviously, we replace this with OpenGL shader and we fill in the gaps. So this becomes a create function, which takes a shader, which is in the shader namespace, and then we have, that's all correct. Vertex source and fragment source ends up here. That looks pretty good to me. So it doesn't seem very happy because I've got a semicolon at the end. If we try and just Control F7 that to compile this file, see if that works. It does, great. Okay, so that's basically the change that we've made. So right now, obviously, we'll be creating an OpenGL shader pointer every time we do this. On the topic of pointers, I'm getting really quite sad at seeing these raw pointers absolutely everywhere in the code right now. They should basically be some kind of form of reference counted object. So in other words, in our case, without writing our own, that would be a shared pointer. I'm really keen to move over into that system. We might even do that next episode because as I mentioned, I am getting a little bit annoyed with this, and the more of this we write, the more we'll have to replace later. You'll see how we do that when we do cover that, because, and again, it's stuff that's done obviously in Hazel Dev already, but maybe that's worth doing next time. So potentially that will be the next episode. In fact, I think I will, because it's just kind of like this almost boilerplate code that just needs to be written, and then we can just forget about it. It's kind of like the core Hazel library stuff that needs to be written, the core stuff. Okay, fantastic. So that's it. That is 100% the end of this class. This renderer ID obviously gets removed because this shader class should have no data, and we don't really need GLM here at all. Nor do we need string. Okay, cool. So I think GL shader already has that, to be honest, which I can't search for annoyingly. Okay, so we just have shader, so we do need GLM just because we have this stuff over here. So that is looking pretty good. Obviously, we need to do some find replace stuff here. So open GL shader. I'll quickly just replace shader : with OpenGL shader : inside this document, and then patch up these two things, the constructor and the destructor. All right, that I think is about it for what we need to do here. So what I'll do is probably test this out now. If we go to Sandbox app, you'll see hopefully that if I compile Hazel, especially if I compile Hazel, but we shouldn't even need to compile Hazel for this to happen. If we take a look at where we've written our shaders, and you can see the arrows are popping up, you'll see that we can't actually create Hazel in the same way. And one last thing that I'll do actually is, that's fine, it's in the renderer. We'll deal with that in a minute. So inside sandbox app.cpp, you can see that we can't actually create a Hazel shader anymore because we can't go new shader, just like we can't go new vertex array because it's an abstract class. So we'll have to do Hazel shader create, just like we have to do with all of our other kind of renderer like resources. Okay, there we go. So we create that instead of newing it, and then we have a fantastic problem that we have to deal with. So, and the same thing, by the way, is inside the renderer class when we try to upload these uniforms. Shader is currently a shared pointer that is of type shader. What we need to do is actually cast it into an OpenGL shader. Now we know it's an OpenGL shader because that's the only thing it could possibly be. And by the time it could be like a DirectX shader or a Vulkan shader, we will have far like rewritten the system, gotten rid of it, and made it actually abstract. But since we haven't right now, we basically have to cast this. So to do that using, proper C++, I guess, we'll have to do either a static cast or a dynamic cast. Technically speaking, we could easily do a static cast because we know what it is. We don't need to do any kind of validation to make sure it's that. But just for the sake of being nice, I guess, we'll do a dynamic pointer cast into OpenGL shader like that. So std dynamic pointer cast, and then the type we want to cast into. So we'll have to include obviously platform, OpenGL, and OpenGL shader for that to work. And I'll just copy this and paste it into here. Okay, so now what we're doing, and in the future we can easily just search for, std dynamic pointer cast OpenGL shader, just search for basically this string, and then replace that all with just, not casting it at all because we won't need it anymore. Even though that doesn't make sense because we'll have to remove this function anyway, because upload uniform mat4 is not an abstract function, it's a GL shader only function. Great, so that's what we end up with, and we have to do the same thing in Sandbox app. In this case, we're going to change the way the system works though, so it'll be a little bit different. Basically what we need to do is, and the thing is, this doesn't get bound ever, so we do a uniform without binding. Not a great idea. The reason that may have worked before and did work before is just because I think is that the only shader we have? I'm actually quite surprised that worked, to be honest, because the shader was never bound. And that's a bit dodgy, but let's bind the shader. So we'll do flat color shader bind, and again we'll have to just copy that. We'll have to do a few things. We'll have to copy this include from the renderer into the top of Sandbox like that, and then we'll have to, since that's actually part of Hazel, I might put it like first like that. And then we'll have to do Hazel OpenGL shader to cast into our type. There we go, bind. And then what we'll do is we'll actually upload. So red color, blue color, that's all great. What I'll do is I'll actually create a member here because we're going to tie this in with IMGUI, as I mentioned. So this will be a GLM vec3 square color. We'll set this equal to 0.2, 0.3, 0.8, like we did before. We'll just have it as a vec3. I mean, the alpha is going to be 0, so we might as well just have it as a vec3. Which means we'll have to add the right function. So we have this as a, we'll do the upload here. So we'll have to do an upload uniform float3, which we don't have yet, but will. The name will remain as u_color, and then the value will be square color. Okay, we've already written everything else. We'll get rid of this stuff and just do the transform and the position inside here. So this will just kind of, again, if we had a material, it would be in the material, but we don't, so it's here. But when we have materials in the future, we'll rewrite this. We'll get rid of the red color and the blue color from here because we don't need them anymore. And then the final thing is we need to create all these functions. So let's go ahead and make that happen. So inside OpenGL shader, we're going to basically duplicate this a bunch of times. We'll have upload float 2, float 3, and float 4. We'll probably have an int as well, so upload uniform int. We'll definitely need that for things like samplers when we need to upload those. Int 2, int 3, int 4. We probably won't make functions for that just yet. We definitely could. I'm just trying to think what on earth they'd be used for. And int 3 would probably be quite useful for like bone indices, but again, we're not dealing with animation anytime soon, so I think that's too useful right now. So I'll deal with that in the future as we need it. I'll do mat3 though, because that could potentially be useful. Okay, so we've got all of this sorted out now. So we've got all these. I can just right click here and use Visual Assist to create all of these things. Okay. And then back here, and so you put them in the right order, which is great. What I'll do is just copy this code absolutely everywhere. So this location should, as I mentioned last episode, should already be here because we should have parsed the shader, got all the shader values out. We'll deal with that in more depth in the future for sure. But for now, we'll just get the location every single time. we shouldn't really notice any kind of performance decrease from that, even though it isn't the most efficient thing to do, just because we're not dealing with any kind of large scale rendering at the moment. So don't worry too much about that if you are slightly worried. Okay, 2F and 3F. What you could do is actually cache these locations. As like a quick thing, you could either like retrieve a list of active uniforms from OpenGL, but a technique that a lot of people tend to do is actually cache the uniforms in like a map, like a hash map, so that you don't and then the hash map is based on the name of the uniform, and then the actual value is the location. So you can just easily kind of retrieve the location only once and cache that value and then reuse it, since the location is not going to change. I actually have a video. I think yesterday I probably released a video on that. I haven't made the video yet, but I'm going to make it and then release it. And actually this video will be released after I release the other video, which is weird because I haven't made the other video yet. But long story short, OpenGL caching uniforms video up there. Check it out if you haven't already. If you want more details about how to cache these uniforms and stuff, because I thought I'd make a specific OpenGL series video about that. Okay, so value, this becomes value.x, value.y. In case I'm going a little bit too fast and you're not following along, all I'm doing here is just creating very, very basic functions that are pretty much the same, but they actually deal with different types. So in other words, we're dealing with a 3-component vector here, a 2-component vector, a 1-component vector, or just a float, and then like a 4-component vector, like a vec4, which is just 4 floats that we're uploading to the GPU in the form of a uniform, so that we basically can upload any type of data we want and not just float 4s and mat 4s, which is what the only thing that we could do before. So this becomes 3FE, and that is literally the only thing that changes. Amazing. Okay, really simple. Make sure that you don't make any mistakes. 4, 3, 2, 1 sounds good, and 1i, of course, for the integer. Okay, that's it. That's all we have to do. Now we have all of these functions, and we can obviously use all of them, like upload uniform float 3, for example, should be completely fine. Here's the function. Okay, so that's how that works. Let's go ahead and add this m² color vector to our IMGUI controls. Really, really easy to do. I don't think we've done that before in IMGUI, but I'll show you how simple it is. We basically just do IMGUI begin to make a new window. I'll call this window settings. And then every IMGUI begin needs to have an IMGUI end as well. And then in between that, we put basically a list of UI controls that we want. So what we'll do is we'll make a IMGUI color edit 3, which is just a little kind of color edit UI control that we can click on to bring up a color picker. We'll call this our square color, and we'll give it a GLM value pointer, which is going to be our square color, just like that, okay? And for value pointer, I think we need an include, which is this one. I'm just stealing it from OpenGL shader, just like that. And that's it. Like, these 3 lines of code are going to give us a nice little UI so that we can change the square color at runtime, and everything else should work. Let's hit F5 and see what happens. Okay, so that did not work as expected. All of our squares are actually black, which is fantastic, but you can see that at least they are in the proper positions, which means that obviously the transformation matrix and all that stuff worked. So for some reason, our flat color shader did not seem to work with this. So let's take a look at this. Oh, it's a vec4. So we changed it to a vec3. Make sure that you don't forget that change. And then over here, we'll just do vec4 ucolor and then 1.0 for the alpha. Let's hit F5 and this should now work. All right, and as you can see, we have our Hazel engine running with this kind of UI control here with the square color. So what we can do is now just click on this, brings up a color picker, and you can see that we can change it to really any color we want. And all of the squares are updated with that color. So definitely very cool, and it shows that all of our uniforms are in fact working dynamically. All right, so I hope you guys enjoyed this video. If you did, you can hit that like button. You can also help support the series by going over to patreon.com/the Cherno and get access to a lot of really cool things. I've started doing this new thing on Patreon where I actually make exclusive videos just for patrons. So this isn't like some kind of massive like conspiracy of, oh my gosh, Cherno's suddenly releasing all of his like really good content just for patrons behind a paywall. No. What I'm actually doing is just making little videos as I work on the real videos, just with little notes. So while I'm developing Hazel Dev, right, which is kind of my personal Hazel development branch, which you can also access through Patreon, which is where I've got like the PBR renderer and all of that stuff. Or I'm just kind of just thinking about another video that I'll make kind of like a development log that's just like, hey guys, so this is what I'm thinking of doing. I'll just type out some code to make sure it works. You know, this is what I've been doing in a Hazel Dev. This is what the code looks like in Hazel Dev. This is what I'm thinking about doing for the next episode of the Game Engine series for specifically the Hazel that's public. That kind of stuff where it's like, I mean, last time I released it was like a 25-minute video of me just having a casual conversation. It's almost like a meeting or something that I'm just kind of like discussing with you guys like, hey, this is what I'm doing. Most of the content that I say there does eventually make its way to YouTube videos, but this is just like a kind of exclusive, like behind the scenes look, and more of like kind of a discussion where you guys can also leave comments and make suggestions, and like, it's just something that I do kind of as I work on stuff back at my office. So if you're interested in that, definitely help support. To get those videos, by the way, it's like $3 a month. It's the lowest Patreon tier, and you get access to all those Patreon videos. I'm trying to do like 1 or 2 a week, but at least 1 a week. So definitely check that out and help support the series, because your generosity makes this kind of stuff possible. And I love doing this kind of stuff so much. So next time, as I mentioned, probably take a look at reference counting and that kind of stuff, because the more we leave it, the more work we'll have to do later. Might not be the most thrilling episode, but it's just core kind of engine stuff that really does need to get done. And as I mentioned before, there's going to be one final poll just to determine whether or not we're going to do 2D and 3D. Just so you guys know, and you can check that out by just looking at the last video. It was like 2/3 of you voted for 3D and 1/3 of you voted for 2D. So it is very likely going to be 3D. So I've already started planning 3D actually, and that's probably the direction that we'll actually take. But again, one final poll, there'll be a description, there'll be a link in the description. If you go to my channel, it's in like the discussion page. Some of you may have already seen it pop up on your like feed, because I'm just gonna publish it as like a poll post through YouTube. So definitely make sure that you go there and vote, and also leave a comment like suggesting maybe why you voted for this and why you want that, so that you can get more people on board to vote for what you want. And this will kind of be the final decision as to which way we take this Hazel YouTube series. Hope you guys enjoy this video. I'll see you next time. Goodbye.